Now that we talked about real numbers, including rationals and irrationals, and we check the number system, we're going to talk about real number line and rectangular coordinate system. Real number line includes all real values. Sometimes we call it x-axis. Then we take x-axis and y-axis, which are basically real number lines perpendicular to each other and form rectangular coordinate system, or another name for it, Cartesian coordinate system. These two lines divide up the plane into 4 quadrants. In the first quadrant, x and y are positive. In the second quadrant, x is negative, y is positive. In the third quadrant, x is negative, y is negative. And in the fourth quadrant, x is positive and y is negative. Relation in x and y. Now, if we take points from Cartesian plane or rectangular coordinate system, we call that a relation. So a relation is basically a bunch of points in the plane. Each relation has domain and it has range. The domain is the set of first components, and the range is the set of second components. For example, this relation has 3 points. X is 45, y is 65. X is 48, y is 68. X is 41, y is 62. So basically, following the definition of domain, which is the set of first components, all x values, you have 45, you have 48, and you have 41 in the domain. To form the range following the definition is the set of all second components. Second components or y values, 65, 68, and 62. These are all the values or members of the range. Sometimes we use some arrows to define or represent the relation. This relation has x values, 3 to -7, and 1 y value, which is -9. The way that we write it is 3 is related to -9, so 3 and -9. 2 is related to -9, so x is 2, y is -9. -7 is related to -9, so the third point is -7 and -9. In this relation, we have 4 points. This relation is not a function. It doesn't pass vertical line tests, so it is called a relation. This relation has 4 points. 1 and 2, -3 and 4, 1 and -4, 3 and 4. The domain includes 1, -3. You don't have to repeat 1 again because you already have 1 here, and 3. The range includes 2, 4, -4, and you don't have to repeat 4 again. Sometimes we have to use interval notation to represent the domain and the range of a relation or a function. So take a look at the domain of this curve. The domain is all possible values that are on x-axis and related to this relation or curve. The range is on the y-axis. For example, here you have a piece of curve. The domain includes numbers from -4 to 2, but all of these numbers are included. We cannot count them, we cannot list them. So instead, we have to use interval notation. The range of positive values, y values, between 1 and 4. So we have to use interval notation. We cannot list these numbers. We cannot separate these numbers. There is no gap here. The open interval a, B with open parentheses is all values between A and B are not included. When you use bracket, it means that endpoints are also included. If you have a bracket, then open parenthesis, it means that A is included, but B is not included. And so on. Let's take a look at this relation here. This relation is not a function. It doesn't pass vertical line test. The domain of this relation starts at -8 and stops at 8. So the domain is closed interval, -8 to 8. The range is in between -5 to 5. All of these numbers are included in the range. So we have to use a closed interval. Take a look at this piece of line. The very first point is not included in the line. The terminal point is included. So when we write the domain, the projection on x-axis, -3 is not included. So we use open parenthesis for -3. 2 is included. The point, terminal point is included. So we use a bracket for 2. For range, it is between 1 and 2, but 1 related to the initial point is not included. So that's why you use open parenthesis. 2 related to the terminal point is included, so we use a closed bracket.